In the battle against disease, drugs play a critical role by either relieving symptoms or directly curing the underlying cause. Some drugs, known as symptomatic treatments, are designed to alleviate the discomfort and distress caused by illness. For example, pain relievers like ibuprofen or acetaminophen reduce fever and relieve pain but do not address the root cause of the disease. These medications provide comfort and make it easier for the body to cope with the illness while the immune system works to overcome the infection. Other drugs, however, go beyond merely alleviating symptoms and target the specific pathogens or mechanisms that cause the disease. Antibiotics, for instance, are a class of drugs that cure bacterial infections by killing the bacteria or inhibiting their growth. By directly targeting the bacteria, these drugs eliminate the infection, allowing the patient to recover fully. Similarly, antiviral drugs can inhibit the replication of viruses, helping to control and reduce the severity of viral infections. Despite the effectiveness of antibiotics in treating bacterial infections, there is a significant challenge in their use: bacterial resistance. Bacteria can become resistant to antibiotics through a process of natural selection. When antibiotics are used, they kill the susceptible bacteria, but any bacteria with a mutation that makes them resistant to the drug can survive and multiply. Over time, this can lead to the development of antibiotic-resistant strains of bacteria, which are much harder to treat. Misuse and overuse of antibiotics, such as taking them for viral infections or not completing the prescribed course, accelerate this process. Resistant bacteria pose a serious public health threat because they can cause infections that are difficult or even impossible to treat with existing antibiotics. This has led to a growing emphasis on the careful and responsible use of antibiotics, as well as the development of new drugs to combat resistant strains. Many drugs that are used today have their origins in plants, a fact that highlights the deep connection between nature and medicine. For centuries, humans have used plants for their medicinal properties, and many of these traditional remedies have been scientifically validated and refined into modern drugs. One of the most famous examples is aspirin, which was developed from salicylic acid found in the bark of willow trees. Similarly, the heart drug Digitalis is derived from foxglove plants, and the cancer treatment paclitaxel, Taxol, comes from the Pacific yew tree. The discovery of penicillin, the first antibiotic, was also rooted in nature, as it was derived from a mold known as Penicillium. The reason plants are such a valuable source of drugs is that they produce a wide variety of chemical compounds as part of their natural defense mechanisms against pests, diseases, and environmental stressors. These compounds can have powerful effects on human biology, and by studying them, scientists have been able to develop drugs that target specific diseases or symptoms. The continued exploration of plant-based compounds is crucial for the discovery of new drugs, especially in the face of challenges like antibiotic resistance. The development and use of drugs, whether for relieving symptoms or curing diseases, are central to modern medicine. However, the challenges of drug resistance and the need for new treatments underscore the importance of responsible drug use and continued research into natural sources for potential new therapies. By understanding and addressing these challenges, we can continue to improve our ability to fight disease and protect human health.